In this video, we are going to be finding zeros using the synthetic division. So let's look at the warm-up. It says state the possible rational zeros for the function. Then use synthetic division to factor the polynomial function completely and find all zeros. So this is asking us to do three things. Find the possible rational zeros, the PRZs. Then they also want us to factor the polynomial completely. So that's the second thing. And then they want us to find all zeros. So we're getting three different things here with this problem. F of x equals x cubed plus 2x squared minus x minus 2. The first thing that they want us to find are the possible rational zeros. So my constant term is 2. The factors of 2 are 1 and 2. My leading coefficient is 1. The factors of 1 are 1. So to find my possible rational zeros, you always do your plus or minus p over q values, where your constant is p and your leading coefficient is q. And so I'm going to take each constant factor and divide it by each leading coefficient. All of these are always plus or minus. That's why I didn't have a negative 2 here, because the plus or minus takes care of the fact if it's positive or negative. So 1 divided by 1 is 1, and 2 divided by 1 is 2. So my possible rational zeros are plus or minus 1 and plus or minus 2. The second thing they want us to do is factor completely. So to do that, I'm going to use synthetic division. I'm going to try one of my possible rational zeros, and I'll keep trying them until I get a remainder of 0. I always start with 1. You can start with whichever possible rational zero you want. I always begin with 1 because 1 is the easiest number. So if 1 is my 0, let's see. My coefficients are 1, 2, negative 1, and negative 2. Always bring down your first coefficient, and then whatever is last is your remainder. 1 times 1 is 1. 1 plus 2 is 3. 1 times 3 is 3. Negative 1 plus 3 is 2. 1 times 2 is 2. Negative 2 plus 2 is 0. So this is a 0, so that's nice. And so now I can find my factors. So my first factor, if x equals 1 is a 0, then that means that x minus 1 is a factor. We started with x cubed, so that means with my synthetic division, my quotient starts with x squared. So here I have x squared plus 3x plus 2. We want to factor the function completely, meaning we want to try to get linear factors. X minus 1 is already linear, so I want to factor this trinomial completely. This trinomial is quadratic. So I'm looking for factors of 2 that add to 3, and that's going to be 2 and 1. You could also have used the area model to factor this. So this is the second thing that we were looking for, the factors. And now I want to know the zeros. So to find the zeros, I'm going to set each of these factors equal to 0 and solve. So I'll have x minus 1 equals 0, and I'll have x plus 2 equals 0, and I'll have x plus 1 equals 0. To solve this first equation, I'll add 1 to both sides and get x equals 1. For the second equation, I'll subtract 2 on both sides and get x equals negative 2. And on this last one, I'll subtract 1 on both sides and get x equals negative 1. I do not have any multiplicities here, so my solutions are x equals 1, negative 2, and negative 1. What we're going to be doing today is very similar to this, but let's look at this first example and see what it says. It says to factor each and find all rational zeros given 1 0. So that's nice. That means we don't have to find the possible rational zeros. Remember to always look for a greatest common factor first. So on example 1, we're given g of x equals 5x to the fourth plus 3x cubed minus 45x squared minus 27x. And then we're given 3. This number 3 is a 0. This means that x equals 3. So whenever we're factoring, we always want to look for a greatest common factor first. So when I look at my polynomial, I do have a GCF. My GCF is x. So let's go ahead and factor that out first. So I'll have x times 5x cubed plus 3x squared minus 45x minus 27. And I want to factor completely. So I'm going to use the 0 of 3 that they gave me to factor this cubic function here. So I have 3 here, and my coefficients are 5, 3, negative 45, and negative 27. Always bring down your first coefficient. And because they told me that 3 is a 0, I should get a 0 as a remainder if I do everything correctly. So let's see. 5 times 3 is 15. 3 plus 15 is 18. 3 times 18 is 54. Negative 45 plus 54 is 9. 3 times 9 is 27. Negative 27 plus 27 is 0. So let's look at my factors real quick. The first factor I have is x from my GCF. The second factor I have, well, if 3 is a 0, then that means x minus 3 is a factor. And then we factored this cubic here, and when we did that, we got 5x squared plus 18x plus 9. And we want to factor this completely. So x is a linear factor. X minus 3 is a linear factor. Let's factor 5x squared plus 18x plus 9. To do this, I am going to use the area model. So first term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So here I'm looking for factors of 45 that add to 18. Those two numbers are 3 and 15. 3 times 15 is 45, and 3 plus 15 is 18. The greatest common factor in my top row is not 5x, it's just x. The greatest common factor in my bottom row is 3. The greatest common factor of the left side is 5x, and the greatest common factor of the right side is 3. Remember that when you are factoring, you can always check your work. X times 5x is 5x squared. X times 3 is 3x. 3 times 5x is 15x. And 3 times 3 is 9. So this simplifies to x plus 3 times 5x plus 3. So we have factored. And now we want to find all of the rational zeros. Oops. So I'm just going to set each factor equal to 0 and solve. So I'm going to have x equals 0, x minus 3 equals 0, x plus 3 equals 0, and 5x plus 3 equals 0. So let me go ahead and solve each of these. This one's already solved for, so that's nice. To undo subtraction, I'll do addition and get x equals 3. To undo addition, I'll do subtraction and get x equals negative 3. And on this last one, I'll subtract 3 on both sides and get 5x equals negative 3. Divide both sides by 5 and get x equals negative 3/5. There are no multiplicities here, so my solutions are 0, 3, negative 3, and negative 3/5. Let's go ahead and try that again with example 2. With example 2, they tell us that f of x is equal to 3x to the 4th minus 4x cubed minus 75x squared plus 100x. And that the 0 that they give us is 5. Remember that you always want to look for greatest common factor first. Here my greatest common factor is x. So I'm going to have f of x equals x times 3x cubed minus 4x squared minus 75x plus 100. So I'm going to use that 0 of 5 that they gave us to factor 3x cubed minus 4x squared minus 75x plus 100 by using synthetic division. My coefficients are 3, negative 4, negative 75, and 100. You always want to bring down your first coefficient, and then whatever you get last is your remainder. 5 times 3 is 15. Negative 4 plus 15 is 11. 5 times 11 is 55. Negative 75 plus 55 is negative 20. And 5 times negative 20 is negative 100. 100 minus 100 is 0. So right now my factors are x from my GCF. And then if 5 is a 0, then x minus 5 is a factor. With my synthetic division, I started with x cubed, so this is going to be x squared, x to the 1st, and x to the 0th power. So this factor is 3x squared plus 11x minus 20. We always want to factor completely. So I still need to factor 3x squared plus 11x minus 20. And to do that, I'm going to use the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. So I am looking for factors of negative 60 that add to 11. So let's see. My factors of 60 are 1 times 60, 2 times 30, 3 times 20, 4 times 15. That could work. Let's see. If I have negative 4 and positive 15, that gives me negative 60. And negative 4 plus 15 is 11. So it's going to be negative 4x and 15x. The greatest common factor of this top row is x. The greatest common factor of this bottom row is 5. The greatest common factor of the left side is 3x. And the greatest common factor of the right side is negative 4. So here my factors are x times x minus 5 times x plus 5 times 3x minus 4. So those are my factors. And now I want to find my zeros. So I'm going to set each one of these equal to 0 and solve. So I'll have x equals 0, x minus 5 equals 0, x plus 5 equals 0, and 3x minus 4 equals 0. So this one's already solved for. Over here, I'll add 5 to both sides and get x equals 5. Here, I'll subtract 5 on both sides and get x equals negative 5. And then last but not least, add 4 to both sides, get 3x equals 4, divide both sides by 3, and get x equals 4/3. There are no multiplicities, so my solutions are 0, 5, negative 5, and positive 4/3. Go ahead and pause the video and see if you can try example 3. So on example 3, I want to solve for x, and they give us a 0 of negative 3. My function is g of x equals 2x to the 4th plus x cubed minus 40x squared minus 75x. We always want to look for greatest common factor first. Here my GCF is x. So I'm going to have g of x equals x times 2x cubed plus x squared minus 40x minus 75. I always want to factor completely, and so now we're going to use the 0 they gave us in synthetic division to find more factors. So negative 3 is going to be in the top left-hand corner. My coefficients are 2, 1, negative 40, and negative 75. I'm going to bring down that coefficient of 2. Negative 3 times 2 is negative 6. 1 minus 6 is negative 5. Negative 3 times negative 5 is positive 15. This is going to give me 25. Negative 3 times 25 is negative 75. Well, this should be a negative 25, giving me a positive 25. There we go. Oops, positive 75. And that gives me 0. So I have x as a factor from my GCF. And then I have negative 3 as a factor, or if negative 3 is a 0, then x plus 3 is a factor. I started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So here that factor is 2x squared minus 5x minus 25. We do want to factor completely, and so that means that we want linear factors. X is a linear factor, and x plus 3 is a linear factor. So now I want to factor 2x squared minus 5x plus 25. To do that, I am going to use the area model. And so I'll have 2x squared and negative 25. 2 times negative 25 is negative 50. So I'm looking for factors of negative 50 that add to negative 5. And that is going to be negative 10 and positive 5. The greatest common factor of my top column is 2x. The greatest common factor of my bottom row is 5. The greatest common factor of my left column is x. And the greatest common factor of my right column is negative 5. Let's check and see if that works. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 5 times x is 5x. And 5 times negative 5 is negative 25. So this simplifies to 2x plus 5 and x minus 5. So we have factored completely, and now we want to find all of our rational zeros by setting each one of these 4 factors equal to 0 and solving. So I'll have x equals 0, x plus 3 equals 0, 2x plus 5 equals 0, and x minus 5 equals 0. X equals 0 is already solved for. For the second equation, I'll subtract 3 on both sides and get x equals negative 3. For the second equation, I'll subtract 5 on both sides and get 2x equals negative 5. Divide both sides by 2 and get x equals negative 5 halves. And for the last equation, I'll add 5 on both sides and get x equals 5. There are no multiplicities here, so my solutions are 0, negative 3, negative 5 over 2, and positive 5. If we look at example 4, we are given h of x equals 2x to the 4th plus 15x cubed plus 27x squared plus 10x, and they give us negative 2 as a 0. First thing we want to do is look for a greatest common factor. Here I have a greatest common factor of x. So I'm going to have h of x equals x times 2x cubed plus 15x squared plus 27x plus 10. And I want to factor completely, so I'm going to use the 0 that it gave me of -2, and that is going to go in the upper left-hand corner. My coefficients are 2, 15, 27, and 10. You always want to bring down that first coefficient. -2 times 2 is -4. 15 minus 4 is 11. -2 times 11 is -22. 27 minus 22 is 5. -2 times 5 is -10. 10 minus 10 is 0. My first factor is x from my GCF. My second factor is, well, if -2 is a 0, then that means x plus 2 is a factor. And then we started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So here these factors are 2x squared plus 11x plus 5. We do want to factor completely. X is a linear factor. X plus 2 is a linear factor. And then I want to factor 2x squared plus 11x plus 5 completely. To do that, I am going to use the area model. First term goes in the first box. Last term goes in the last box. You always want to multiply your first number by your last number. So here I'm looking for factors of 10 that add to 11, and that is going to be 10 and 1. The greatest common factor of my top row is 2x. The greatest common factor of my bottom row is 1. The greatest common factor of the left column is x. And the greatest common factor of the right column is 5. So here, this factors into 2x plus 1 and x plus 5. From here, I want to set each of my factors equal to 0 and solve. And so I'll have x equals 0, x plus 2 equals 0, 2x plus 1 equals 0, and x plus 5 equals 0. X equals 0 is already solved for. For the second equation, I'll subtract 2 on both sides and get x equals -2. Over here, I'm going to subtract 1 and get 2x equals -1. Divide both sides by 2 and get x equals -1/2. And then over here, I'll subtract 5 on both sides and get x equals -5. There are no multiplicities, so my solutions are 0, -2, -1/2, and -5.